Hello, my name is Ismo Lehtonen. I'm the Sales and Marketing Director of Adwatec. And here today with me is Heikki.
Hi there.
Heikki is the Managing Director of Adwatec. Today's topic in this episode is redundant cooling system for marine. Heikki, would you please explain what is the redundant cooling system, how it will be created, and what does it actually mean?
When discussing about redundancy, it's important to take some distance and not focus on the cooling system alone, but look at the big picture. The redundancy in general is required in critical applications, for example in the propulsion applications. The system shall be built so that if something fails, there's a backup system that steps in and continues operation. Thus the redundant system operation is built in the ship's engineering process. The cooling system is just one part of this total concept that will be used.
Thank you, Heikki. That was a very good clarification and explanation. My second question will be that would you please explain how to build the reliable redundant cooling system?
Okay, so this goes back to this engineering piece, how the main approach to redundant solution is designed. But from cooling system perspective, purely the simplest way to build a redundant cooling system is to use two separate cooling systems in parallel, one in operation and then the other one as a backup, ready to take action when the first one fails. Now this kind of solution is of course costly. It is practically 2 times the cost of one unit, and then it is also quite large in size, so it requires space. When we look at the redundancy in general in cooling systems or in any kind of system, of course one very important aspect to think about is what really may fail and what may not fail. So our approach here in Adwatec is that we double or back up those components that have the risk of failure, and for those components that most likely will not fail, we have just one piece of those. In practice, this means that in our normal approach, we double or make redundant the pump systems, and we may also make redundant the drive portion of the cooling system. Otherwise, we work with one single system and only those pieces doubled.
Thank you, Heikki. Very good explanation. That was a nice theory, but let's see how it looks like in the practice. So please join us in the Adwatec factory floor and we give you some examples.
Okay, see you downstairs.
See you downstairs. Thank you.
So here we are in Adwatec production, and here on my left I have a basic redundant cooling system for marine application. So the redundant piece is practically 2 pumps, and that's all. Automation and control system here is then taking care of operating the redundancy here. Then in this picture we have a bit different kind of redundant solution. Here also the drives or variable frequency drives portion is doubled. So we are using 2 frequency drives controlling the pumps. And here we have a bit bigger unit, practically everything doubled. So we have 2 pumps here, we have 2 frequency drives here, and then we have heat exchangers also doubled. So one is active, the other one is redundant. This kind of heat exchanger is also easily maintainable, so it can be cleaned and taken back into use again.
Thank you, Heikki, for good demonstration in Adwatec factory floor. If you have any questions, please do not hesitate to contact us at any time. Thanks for watching and keep it cool.